What exactly is an AI agent? Simply put, an AI agent is a piece of software that can perform tasks autonomously or with minimal human intervention. Think of it as a digital worker that can reason, plan, and take action to achieve specific goals. Now, this isn't some far-off sci-fi fantasy. AI agents are being used today in a variety of applications, from chatbots that can handle customer service inquiries to autonomous systems that can manage complex workflows. What makes these agents truly powerful is their ability to interact with the real world through tools. This is where tool calling comes in. AI agents can call upon specialized functions, access external data sources, even control physical devices in your home. They're not just answering questions, they are doing things. Let's talk more about tool calling, because it's one of the most exciting aspects of AI agents. Imagine an agent that needs to book a flight for you. It can use a tool to search for available flights, another tool to compare prices, and yet another tool to actually make the booking. This is all happening automatically, based on your initial request. But tool calling isn't just about automation. It's also about empowering agents to reason and solve more complex problems. For example, an agent tasked with writing a report might use a tool to search for relevant information online, another tool to summarize that information, and then use its own language generation abilities to compose the final report. It's this combination of tool use and reasoning that makes AI agents so versatile. Reasoning is the secret sauce that makes AI agents truly intelligent. Different types of reasoning are emerging in the field. One key type is reasoning through evaluation and planning. This involves breaking down complex tasks, deciding which steps to take, assessing the results, and refining the approach until the task is completed successfully. Think of it as the strategic thinking that goes into solving a problem, similar to chain of thought prompting or the React pattern. Another important kind is reasoning through tool use. This revolves around the specific tools that the agent needs to effectively complete its task. The agent needs to know which tool to use, when to use it, and how to format the input correctly to get the desired result. It's like a master craftsman selecting the right tool for the job and using it with precision and skill. There are many ways to structure or architect an AI agent, and we're seeing a lot of experimentation in the field. One common approach uses a single router, similar to a central decision maker, that selects the appropriate tool or function to call based on the task at hand. This works well for simpler tasks. We see slightly more complicated agents which are grouped together based on what they can do collectively. Rather than directly calling a tool, these agents use a skill architecture to chain together several steps or actions into one skill to solve the user's need, each skill specializing in accomplishing a specific multi-step workflow. This approach is becoming increasingly popular for production applications that need to be reliable, predictable, and easier to monitor. For agents requiring a more iterative approach where the flow of the application is dependent on inputs from previous steps such as external data sources or previous tool calls, we are starting to see more complex and graph-like architectures using agent frameworks like LangGraph and LlamaIndex workflows. For use cases like this, it's important to carefully plan and evaluate all possible paths within the agent workflow to ensure robustness and manage potential errors. Let's talk about LangGraph, a powerful framework from LangChain designed specifically for building AI agents. LangGraph uses a graph-based approach, allowing you to visually represent the steps or nodes in an agent's workflow and the transitions or edges between them. This visual representation makes it much easier to understand and manage complex agent behaviors, especially when dealing with loops and conditional logic. LangGraph allows you to define custom states, nodes, and edges, giving you fine-grained control over how your AI agents operate. Plus, it integrates seamlessly with other LangChain components, making it easy to incorporate features like memory, retrieval-augmented generation, and more into your agent's workflows. This makes LangGraph a very versatile tool for building all sorts of advanced AI applications. LlamaIndex Workflows is another popular agent framework. Similar to LangGraph, Workflows makes it simple to create looping agents, but it takes a slightly different approach. Instead of nodes and edges, Workflows uses steps and events. Each step in a workflow represents a piece of logic or a task that the agent can perform. Steps communicate with each other by emitting and receiving events. This event-driven architecture promotes flexibility and makes it easy to build complex agents that can handle various scenarios asynchronously. LlamaIndex Workflows also integrates tightly with other LlamaIndex components, giving you a full suite of tools for building your AI agents. Now let's talk about Autogen, a popular agent framework from Microsoft. Autogen specializes in tasks involving code generation and execution. It treats agentic workflows as conversations between different agents, each with its own role or expertise. This conversational approach to agent design is very intuitive and easy to understand. Autogen also excels at tasks requiring the exchange of code between agents, making it a valuable tool among developers building larger applications involving multiple steps. One area where it really shines is in applications where one of the agents suggests that code should be generated, and then another agent executes that code in some sort of sandbox. This makes Autogen particularly well-suited for tasks like data analysis, report generation, or any application that combines LLM reasoning capabilities with the execution of code. Finally, let's look at Crew AI, a relative newcomer to the agent framework scene. Where LangGraph might take a low-level, high-control approach, Crew AI prioritizes ease of use and rapid development. It provides a simple and intuitive interface to build complex agent workflows. Crew AI excels at building applications involving multiple agents, each with predefined roles, working together seamlessly to achieve shared goals. Like LangGraph, it supports a set of other functionalities such as streaming intermediate agent states, shared state between agents and applications, and agent question and answer. It also incorporates best practices like role-playing and guardrails, ensuring your agents behave as intended. If you're not as familiar with agent architectures, or if you value rapid prototyping, then Crew AI might be a good option. While frameworks can be helpful, sometimes it's better to build your agent yourself. This allows for direct control and is well-suited to use cases where many different models or custom libraries are being called together. Code-based agents provide maximum flexibility and integration with whatever custom tooling or models you are using internally. However, this approach involves a lot of careful planning, especially around prompt engineering for routing logic and handling different outputs formats from various components. You'll also need to implement the loops and conditional logic yourself, which can get quite complex as your agent evolves and might mean more ongoing debugging and testing. But if you want to ensure that nothing in a prevailing agency framework slows you down, then building an agent from scratch might be the best option. Now, let's get into some real-world applications of AI agents, because these things are already being used today in some pretty cool ways. One example is using agents for equity research, where companies like Captide are leveraging tools like LangGraph and Langsmith to analyze mountains of financial data and extract valuable insights for investment decisions. Another exciting use case is in disaster preparedness, where Storm, an AI research writing system developed by Stanford, is helping people access and synthesize information from FEMA documents about how to plan for and respond to various emergencies. We're even seeing AI agents being used in fantasy football. One developer combined Sleeper API with LangGraph and Streamlit to provide up-to-the-minute, personalized recommendations for his team. Building and deploying AI agents comes with its fair share of challenges. One of the biggest hurdles is ensuring that agents behave as intended. LLMs are prone to hallucinations, and these can be amplified in agentic workflows. This is where things like guardrails and tracing become essential, allowing you to monitor your agent's behavior and correct errors. Another challenge is managing complexity. As agents become more sophisticated, their workflows can get quite complicated. This is where agent frameworks and careful planning can really help, providing a structure to manage the various steps and interactions in your agent's logic. Other concerns include high cloud costs for large models and the need for powerful edge hardware to run open-source LLMs. However, despite these challenges, the benefits of AI agents are immense, so it's worth investing the time to thoroughly understand potential risks and create mitigations before deploying your application. The field of AI agents is still very much in its early stages, but it's clear that these systems have tremendous potential to reshape how we interact with technology. We're already seeing the trend of dividing up one complex agent into many smaller, simpler agents working together, similar to what is going on with swarming and routines in OpenAI's new experimental agent framework. We're also seeing more emphasis on human-in-the-loop systems, where humans can oversee and guide the behavior of AI agents. This human-AI collaboration is essential for building trust and ensuring that agents act responsibly. As the technology matures, we can expect to see even more sophisticated agents that can handle an even wider range of tasks. With the growing emphasis on multimodal learning, LLMs are becoming more capable. Multimodal Q&A systems are able to take in images, video, and other forms of data, not just text. Just check out how Microsoft's Florence 2 model is working in combination with LangGraph to add intelligence to video content. And with the growth of embedded LLM support for new generations of hardware like Amazon's Trainium and more recent devices such as Inferentia 2 from AWS, it's quite likely that the edge and local LLM abilities will grow alongside cloud-based models, enhancing the reach of this AI. I hope this video has given you a solid overview of AI agents and the exciting advancements in the field. This field is rapidly evolving, with a lot of experimentation and innovation occurring every day, and it's therefore very important to ensure you have good observability tools and metrics for planning, debugging, and monitoring deployed apps. Whether you opt for a code-based approach or you decide to use a framework such as LangGraph, having tools like OpenTelemetry, New Relic, and Langsmith at your disposal can make all the difference when diagnosing and preventing errors in your agent logic. Check out the resources I have listed in the video description, which include the code for today's examples, links to various agent frameworks, and other useful guides. I encourage you to explore these resources and start building your own AI agents. I'm grateful for your time and attention because it means the world to me. And if you're as fascinated by AI agents as I am and are interested in seeing more on this topic, let me know in the comments and I'll be sure to make more videos like this in some of our coming episodes. Until next time, keep exploring and always be learning.